Hi everyone. In this video on financial math for Actuarial Exam 2, we're going to take a look at problem 1.2.17 in Broverman. It's a starred problem rather than an S problem. Now remember, S problems correspond to problems on old exams. Starred problems correspond to problems that are a little difficult, more difficult than typical, a little bit more depth, although I don't think this particular one is too difficult. And here is the statement. Smith wishes to buy a TV set and is offered a time payment plan. So this is a payment plan over time, whereby he makes 24 monthly payments of 30 each starting now at time 0. So he's going to get the TV and start making payments right away. However, Smith wants something different. Smith wants the payments to start in 2 months rather than now. So Smith is going to save some money because of this. His payments are going to start until a couple months from now. So theoretically, he could take some money he saves right now and invest it to make more money before he starts his payments. The present value of Smith's plan is going to be smaller than the present value of the original plan. We're going to go ahead and use a 1-month interest rate of 1%, so that's 1% per month. What is the present value now of the savings to Smith if the seller agrees to Smith's terms? All right, let's draw 2 number lines. There's the original plan, payment plan starting at time 0. There's 24 payments. So the last payment is going to be 23 months from now. 30 right now at time 0, 30 at 1 month from now, 32 months from now, etc. Again, the last payment, the 24th payment, is going to be at time 23 months from now. And here's the alternative plan proposed by Smith. 0, 1, 2, 3, 4, etc. Then 23, but we're going to go, since we're starting 2 months later at time 2, and we still have 24 payments, that's the assumption. We're not going to be done 23 months from now. It's going to be 25 months from now when that last payment is made. All right. The difference between the present values of these things is going to be the present value now of the savings to Smith. If I take the present value of the original, which will be bigger than the present value of the alternative, and subtract that present value of the alternative, that is going to be the answer to the question. I is our 1-month interest rate, 0.01. V is going to be our 1-month present value factor or present value discount factor. I'm using the word discount sometimes, though soon we're going to talk about a discount interest rate, and it's not the same as the discount interest rate. It's a discount factor. Broverman often doesn't put the word factor in there. It often just calls it a present value factor. It's 1 over 1.01. There's 1.01, take its reciprocal. Looks like it's 0.9900 repeating, evidently. Let me go ahead and store that value in register 0. Press my STO button, then 0. It's now stored in register 0. I'm going to need that. All right, what are the present values of these payment plans, these payment streams? There's the present value of the original. The first payment is at time 0, so that does not need to be taken back into the past. It does not need to be discounted by the present value discount factor, but the other ones will. The second payment at time 1 needs to be multiplied by V. The third payment at time 2 needs to be multiplied by V squared because we're pulling it back in time 2 times to time 0, etc. The last payment is this 30 at time 23. Its present value is 30 times V to the 23rd power. What's the present value of the alternative? It's going to be a smaller present value. Smith can save some money by not paying right away. Again, he could take some money that he's not paying right now and invest it if he wants. It's going to be a smaller present value. It's going to start 30v squared. That first payment is at time 2. Its last payment is at time 25. There is an expression for the present value of the alternative. So the difference between these things, the top minus the bottom, is going to be the answer. Now you don't have to find these sums to figure out the answer, because when you subtract, a bunch of stuff cancels. The answer is this minus that, but a bunch of stuff cancels. This 30v squared cancels with that 30v squared. This 30v cubed cancels with that 30v cubed, etc. The only things that don't cancel are these two things and these two things. You can factor a 30 out. You can write that as 30 times 1 plus v from these two. And we're subtracting these two things over here. I could put minus, and maybe it's best to put in parentheses v to the 24th plus v to the 25th. So you don't need the formula for a finite geometric sum to solve this problem. Certainly when we get to chapter 2 problems, we are going to be using formulas for finite geometric sums. And if you know the formula for a finite geometric sum, you could go ahead and test your skill by finding out what these sums are. But for the purpose of this problem, it's easier just to do what we just did, subtract. All right, so let's see. Use the calculator now. We're going to need the values of v to the 24th and v to the 25th. There is v. Raise that to the 24th power. You get this. Let's go ahead and store that in register 1. Let's also now recall v, RCL0, and raise it to the 25th power. I don't need to really bother storing that, because now I can add that to v to the 24th, which is in register 1. There is v to the 24th plus v to the 25th. Now I think I'll store that in register 1, because I'm going to subtract it. Or I could make it negative. Let's go ahead and make it negative by pressing that button and then adding 1 from that one, and then adding v, which is in register 0. Multiply now by 30. And there we go. The answer is 1268. Yep, see that decimal there? It's a little hard for me to see. That is the decimal. That is the answer. 1268 is the answer. That is the present value of Smith's savings with this alternative payment plan. Again, if you want, I would encourage you to try. If you know or can find out the formula for a finite geometric sum, to figure out these numbers, these summations here, and subtract them to see that you get the same answer. In fact, I can tell you what the answer is. I did it ahead of time. This one turns out to be 643.67, and this one turns out to be 630.99. When you subtract those two amounts, you once again get 1268. Okay, so you can give that a try on your own if you want. Certainly when we do chapter 2 problems, we're going to do lots of finite geometric sums. But for this video, we'll leave it to you.